Okay, well, good morning and good afternoon, everyone, wherever you are. Welcome to the Stencila community call for October. So I'll just start by sharing our presentation, and hopefully we can all see that. And just go through the what we're going to be talking about today. So I'm going to start off by talking about some of our work that we've done on our remote execution engines and give a demo of that. And Jacqueline's going to then talk about Stencila Open, which is a project we've been working on for the past few weeks, and give a walkthrough and demo of that, which is going to be cool. No pressure, Jacqueline. So our Stencila executors are kind of the last piece of the puzzle that we have. So we've already got schema, which is how we represent a reproducible document semantically in JSON. We have encoder, which lets you convert to and from that semantic JSON in a variety of formats, and Jacqueline will show you some of that as well. We have thema, which makes the output document look nice, but we haven't yet had a way to actually execute the document. And that's where executor comes in. And that's a sort of a working name that we have at the moment. And along with executor, we have another sort of project that we're working on, which is called Sparkler, which is used to orchestrate Firecracker VMs. This is a project by Amazon, and they use it in their Fargate service and for Lambdas. And Firecracker is a micro VM, and it has fast startup times, and it's a bit more secure with better host isolation than something like Docker. So Sparkler is a project we have to sort of control a bunch of VMs and start and stop them and so on. So back to executor, the execution process is something like this. Executor will receive a code chunk or code expression, and these are nodes that we defined in our Stencila schema that'll come in JSON. The executor will then look up an interpreter and connect to it. So those interpreters exist currently. They're in our schema project, and we've had those for a little while now, and you can go in there and take an executable document in JSON format and run it through an interpreter, and it'll run it. But it's all sort of it's quite a manual process, and it takes you need to use an entire document. So this is sort of pulling out some of that work so that you can execute just code chunks. So once the interpreter has received the code node, it will execute it and interpolate the values in it. So any output that the code generates or errors it generates will now also be inside that code node. And then executor takes that interpolated node and will send that back to the client. And I'd like to give you a demo of this. So I've got a shell that I've written in Python, which is communicating with executor over TCP. And so it's got an executor backend running that it will send commands to have them execute. And because it's got this executor running, we can execute code in different languages. And there's other front-end interfaces that we can use as well. So just jump to my demo here. So in the screen on the left, I'm running my Python shell, which is reading and executing command. Well, it's not executing commands, but it's reading commands and then sending them over to executor, which is running on the right here. And executor will execute them and send them back. So we can start off really simply with something like a 1 + 1, and we get the output of 2. And you can see the executor has received a code chunk in Python and then executed that. Got some example code which I'm looking for here. Here we go. Okay, so we can also do things like print some output in Python, and we get hello world Python coming out, which executor has executed here. And what if I try something like this? Put in some JavaScript code. Well, obviously that's not going to work because over here I've got Python, and so I get an error saying console.log doesn't exist, which of course it doesn't in Python. but I can change this into JavaScript mode just by doing that. And if I put the code again, we can now see that we're executing some JavaScript over here and getting the output in JavaScript. So that's pretty cool, but like I said, we've got alternate interfaces available. And so what I've done here is just whipped up a pretty simple little web page which lets me put code in and send that through to the executor and have that executed as well. So we do 1 + 1 here, we get the output of 2, and we can see just putting out some the raw response as well, which is JSON RPC data going back and forth. And I can put in some slightly more advanced stuff in here since I have a few lines to work with. So here's some Python code just to get a random number and print it out. I execute that, you see it come through to the executor on the right, and we get our output here. 52 is a good random number. And similarly, another quick example with some JavaScript. Just put this into JavaScript mode, execute that. We now have JavaScript going back and forth, and our minimum value from this list is 23. So that's all I really wanted to show today, is just how we can have a single process running in the background, which is doing the execution, and connect to it from multiple ways, whether it's from a shell or from a web browser or anything like that. And currently this is all just running on my machine, but as I mentioned, we're looking to use Firecracker as a container to host these processes in a secure manner, and to be able to spin up multiple processes for different users and keep them isolated and all that kind of secure stuff. So that's it from me for now. So I'll pass over to Jacqueline.
Thanks, Ben. Okay, so I'll go ahead and share my screen. All right, everyone see my screen okay? Okay, so before I jump into Stencila Open, I want to speak a bit about RPNGs, which you'll see throughout the Stencila ecosystem of tools that help to maintain reproducibility in a research publication workflow. So what's an RPNG? RPNGs are reproducible PNGs. It's our approach to bridging the gap between reproducible documents and legacy formats such as Word documents. So they're static images and figures that contain the underlying code that's used to generate them. Our file converters, namely Encoda, create RPNGs during the conversion process for non-executable formats such as Google Docs, Word files, and PDFs. And this enables collaboration between researchers who work in workflows of varying technical levels. So if one researcher prefers working in Jupyter Notebook or R Markdown and another prefers working in Word and Excel, that's okay. They can still author documents in their preferred format, and Stencila will preserve the source code between conversions. Cool, so now let's return to Stencila Open. So you can find Stencila Open at hub.stencila.la/open. And as you can see here, we provide two options for opening an article. You can enter a file URL here or upload a file from your machine. And right now, we support URLs of files that are hosted on GitHub, Google Docs, if they're publicly viewable, and HackMD for Markdown files. And as far as file upload goes, we support Markdown, Jupyter Notebook, R Markdown, RStudio Notebook, and Word. All right, so let's say that I just finished working on a Jupyter Notebook and I wanted to share this with my colleague. Only they're not so familiar with GitHub or Jupyter Notebook, and they'd prefer editing this in Word if possible. So Stencila Open makes it really easy to do that. So since this is a file that's hosted on GitHub, I can just copy this URL and then back in open, I'll go ahead and paste it. And Stencila open will convert this file into our intermediary format Stencila schema, and that allows it to be converted to various formats such as Word or semantic HTML, such as this preprint that you see here. So as the reviewer of this preprint or the person authoring it, I can hide or show all of the source code if that makes it easier to read. And over here, I have a run button. So as Ben demoed earlier, we're in the middle of turning these code chunks into executable components that viewers can modify and rerun to play with the data and the figures. And we'd be executing Python, R, and JavaScript remotely rather than in the browser using Executa or whatever it's named in the future. And yeah, another feature we have here is the ability to set different themes. Right now, we have eLife, Nature, Public Library of Science. They're based on these different journals, and they have slightly different styles. So this is the eLife theme. And if I'd like to share this with my colleague, I can go ahead and click here and copy this public share link. And right now, they'll stay online for 24 hours after first converting the style. So as the recipient of this share link, let's say I'm a collaborator, I can go ahead and view this article. And in order to edit it as a Word file, I can go ahead and download it. So reproducible Word, docx, that's the Word file that contains our PNGs that I just talked about a little while ago. So the RPNGs are used to preserve the source code between executable formats such as Jupyter Notebook and non-executable formats. And I'll show you RPNGs in action in a little bit. You can also download it as a Jupyter Notebook, R Markdown, JATS XML for publishers, JSON LD, and semantic HTML, which is what we're currently seeing. So I'm going to download it as Word so that I can make some edits. Okay, open this. All right, so over here, so this is the Jupyter Notebook as a Word file. And you can see, let me compare the outputs. They're now static images. So these are RPNGs that the code blocks have been translated to. And the source code is hidden here in these images. So this is done intentionally so that someone opening a Word file with source code wouldn't be able to accidentally modify or delete it. However, once we reopen this Word file in Stencila Open or convert it to an executable format, the source code will be editable again. So I'll do that after making an edit. So let's say this is no longer a work in progress. And I'll go ahead and save it. And I'll go back to Stencila Open and upload my updated file. And now we should have the updated file. It's yes, it's the updated file. And the source code is has returned, even though this was converted from a Word file. And another neat thing that I wanted to point out was here tucked under the More button is the ability to view this semantic HTML page as using Google's structured data testing tool. So this is useful if you want to inspect the microdata that's throughout the article, which is based on schema.org schema, as well as our own custom Stencila schema for nodes that aren't native to schema.org. So here we have some item type and item props microdata that correspond to schema.org's elements. Cool. So we hope that Stencila Open makes your life a little bit easier, and we'd love to hear your feedback. We have this button here. And when you do any file conversions, please let us know what you think. And if you found it useful, or if you found any bugs, then please write a little bit about it. And if you want, you can leave your email address if you'd like to hear back once we resolve these bugs. Thank you.
Thanks, Jacqueline. That was really great. I was just wondering, like, what, in terms of the file formats that we've got to download, have we got any others on the horizon that you can think of that we might be adding soon?
Yes, the Google Docs one, right?
Yeah. Oh, yes, but that's just the first one I think that jumps to mind as being a priority. So the ability to go from the Stencila Open to being able to edit a Google Docs document.
That was really good. I just want to point out, excuse me, I just wanted to point out in terms of the URLs that you can enter, it's not just GitHub and Google Docs and what's listed there. You can put in any URL that you want. We just do special things with those ones.
Awesome. I just today's Jacqueline's last day, so I just wanted to say before we close up the call, thanks very much, Jacqueline, for your time over the last 7 months or 8 months or so. Yeah, it's been fantastic working for you. Really appreciated your talents in both software engineering and product design. And yeah, so it's been great working with you. Thank you.
Thanks, Nakomi. And same with you guys too, Ben and Alex, yeah, and Nakomi.
Yeah, it's been really useful having you, both the technical skills and the design skills. So it's really handy having someone who can jump on both parts there. So we're going to miss you.
Thank you.
Definitely a pleasure. I do have one question for you, Ben, maybe, regarding the demo you gave to kind of put you on the spot. So can you maybe about what the kind of like the strategy is for when you convert between format, say, you know, R, and you convert, IPython notebook, which is in Python, and you convert to R or R Markdown or something. What happens to the code cells that get converted? I guess this is a question for both you, Ben, and Nakomi, maybe. But do we store the output that gets generated and kind of embed that between conversions? Or do we also try to, or are we planning on also trying to convert the actual kind of like...
So we store the language as metadata for the code chunk, as you probably know. And we also store the outputs in the conversion for those formats that do support it. And I believe that iPython notebooks do contain output in their cells, but R Markdown don't. Might be wrong there, but so obviously, as we know, some of our conversions can be lossless. So if we're converting to a format that doesn't support a certain thing, then you'd lose some of that data if you'd come back. So, for example, from iPython notebook to R Markdown, you'd lose that output there. But the theory would be that given these documents are reproducible, we should be able to rerun all that code and hopefully get the same output.
I'll follow up on that a bit. So the, as you say, like in Jupyter Notebooks, we have the outputs of the cells. Those are stored in Jupyter Notebooks as MIME types. And so there might be an image or it might be HTML. And what we do when we're doing the conversion is we convert those to Stencila schema. So everything is represented as a node in that tree that is part of the schema, be it HTML table or an image object. And we do the same thing with our notebooks, which do have store the outputs. So when you're converting between languages, obviously the programming language property of the code chunk stays the same, but the output is a language agnostic, or if you like, representation of the output. So we have written converters that will take, for instance, an R data frame object, which is a column structure representing data. We turn that into a data table in the schema, and similarly for pandas data frame. So we use the schema as a lingua franca for the outputs of code cells, as well as the actual source of the code cell.
Cool. Thank you.
Just another question for Ben too. So could you just go through those steps when you're demoing Executor? Does that, what happens when you switch to JavaScript mode? Does it have like a JavaScript process ready waiting to do that, or is it something that gets spawned up on the fly?
At this stage, the way that it's coded, it just starts all the interpreters on the fly. So it's reading from the manifest files on the disk, which describe what kind of interpreters are available on the host. And it starts up one of each of those when Executor starts. And obviously we can change the logic there, so they start on the fly when the first request comes in, or so on. But yeah, so those are spawned up, they're ready to go. And then when a request comes in, it just checks what language it is and then which interpreter it should be sent off to be executed.
Cool, thanks.
Yeah. All right, thanks everyone.
Thanks.
Okay.
Thanks, Jacqueline.
Okay.